All right, so this is a gas problem, but we're also given a equation to work with. So let's go ahead and start by underlining all of the given information. And because there's a equation that we're given, we're gonna have to use stoichiometry most likely in order to convert from O2 gases to NiO, maybe likely. So, but first, I'll start off by finding out what 40 degrees Celsius is in pressure, because this is a type of problem where um, there's vapor pressure. So, what that means is that when you're given a temperature, you need to convert it to units in pressure and then subtract it from the total pressure. So, there's a chart where you can find out what 40 degrees Celsius is in millimeters mercury. And it's actually going to be 55.4 millimeters mercury. And I'll go ahead and subtract it from 245 millimeters mercury, which gives me 689.6 millimeters mercury. All right, so that's the first step complete. And next, um, I'm going to convert the same temperature into Kelvin as well. The reason being is that we're going to have to use the equation PV equals nRT, and we're going to need a temperature to plug in. So that's going to have to be 40 degrees Celsius, which I'll go ahead and convert to Kelvin. And the way that you do so is that you add 273 to 40, giving me 301, 313 Kelvin. All right, so we're also going to need a pressure, and we already found a pressure here, but we can't use millimeters mercury. We need to convert it to atmospheres. So, and the conversion factor for atmospheres and millimeters mercury is 1 atmosphere over 760 millimeters mercury. And then that will give us 0.907 ATMs. Okay, so the next step would be to just look at this equation. So if we have our pressure and our temperature, we need our volume and N. And we're asked to find the volume. So this is going to be our unknown variable, but we need to find out what N is. And it's here it says here that we're given 24.78 grams of NiO. So we'll go ahead and convert this into moles to start off with. Nickel has a molar mass of 58.7, roughly. Oxygen, it's 16. And when you add those together, 74.7. So let's go ahead and do stoichiometry. 24.78 grams NiO, giving me 0.332 moles. Oh, but we're asked to find the, so it says if oxygen gas is collected over water at 40 degrees Celsius, then that means that we need to convert this amount of nickel oxygen to oxygen gas using the chemical equation. So I'll go ahead and do that right here. And just looking at this equation, it says there's 2 moles here and then just 1 mole of oxygen gas. Which gives me 0.166 moles of O2. So now we can go ahead and plug everything into our equation. I'll go ahead and rearrange it though. So because we're solving for V, I'll isolate it to make everything easier. And then from here, I'm going to go ahead and just plug in. So we found 0.166 moles. And then R is a constant and its value is 0.08206 liters times ATM divided by moles times Kelvin. Temperature we found to be 313 Kelvin. Pressure we found to be 0.907 ATMs. So once you go ahead and plug everything into your calculator, the answer that you should be getting is somewhere around 4.7 liters. And that right there is your answer. Thanks for watching.